My name is Gene Kim. I'm going to be giving the last session, so I want to make sure that I'm very disciplined about hitting the time mark. So what I'd like to do in the next 55 minutes is share with you what has been a now going on 15-year journey studying high-performing IT operations and security and dev organizations. And this initially started when I was the CTO and founder of a company called Tripwire, where it was initially in 1999, we called it geniuses of people with great kung fu. So these were organizations that talked differently, acted differently, but more importantly, they had profoundly different results than your typical IT organization. They had great project due date performance, they had great operations, reliability, and stability and availability. They had great security, they had great postures of compliance. And so really the goal was how do we kind of understand what made them great and document how they made their good to great transformation so others could replicate the transformation. And so the kind of the most surprising part of that journey for me is that it took me straight into the heart of the DevOps movement, which I think is incredibly transformative. That happens once every 30 years, and it has such a huge impact to security practitioners. And I think for me, one of the most memorable things that's happened in the last 5 years is watching Alex Smolin, Neil Matadel, and Justin Collins give a presentation at the AppSec USA conference talking about how Infosec works within the dev and ops teams at Twitter. And my fondest hopes is that by the end of this presentation, you'll agree that, yeah, in some ways, they have sort of transcended the mortal plane, right? And now are experiencing life in a way that we all wish we could, and it's within our grasp. So with that, let me just share with you why I think DevOps is so important, not just for Infosec, but for dev and ops. And it's because there's a downward spiral that happens in almost every organization, and it always can be told in two acts. The first act is always begins in operations. How many people here have done time as a sysadmin in ops or as a DBA or a network engineer, right? And so when you're in ops, right, our goal is to keep systems running so that we can create reliable service for the customer, and that's how we deliver value. The problem is so much of our life is trying to keep things running that are fragile, right? And the reason why we call them fragile is that every time we touch it, it blows up, causes an unplanned outage, catastrophic amount of rework. No one knows how to build a new one, and God forbid we actually need to patch that, right? So the tragedy is that where you find the most fragile artifacts is typically in one of two places. They're in the most critical operations of the organization, maybe the most critical revenue generating infrastructure of the company, or it's in the most critical initiative, right? The most critical project that's meant to close the gap with the competition, bring new capabilities to market. And so when you find fragile artifacts in those two places, in the most critical project, in the most critical operations, right, something inevitable occurs, which is that the organization ceases to become able to, meet the promises that it makes to the outside world, right? Whether it's features we deliver to customers, whether it's earnings per share estimates that we promise to Wall Street, or whether it's trying to show analysts that we can have a viable strategy and can actually execute. And so speaking as a married person, I can say with moral conviction, right, with moral certainty, that when we break promises to someone else, we tend to overcompensate by making bigger, larger, even more audacious promises that we're even less likely to hit in the future, right? And so, that's part of human nature. That's neither good nor bad. The problem is organizations do this too, right? And so the problem is not that, right? The problem is who's making the promises. It's these people, the product managers, the product owners, who are often art majors, creative writing majors, poetry majors even. And, let me just put the rest, right? Some of my best friends are poetry majors. The point is that they're often making large decisions based on maybe not the best grasp of what technology can and can't do, right? And so they make a commitment to the outside world where a commitment has now been made, right? And so now enter the developers. What we now see are urgent, date-driven projects put into the queue, right, where a commitment has already been made, right? So, we can't move the date. And by the way, to explain this joke, of course, in operations, to all you developers out there, we have a joke, right? Show me a developer who's not causing an outage. I'll show you one who's on vacation, right? So, but clearly now that all my friends are in the DevOps community, we can't say that. It's all about the DBAs. Incidentally, one of my favorite jokes I've ever heard in ops was this. They said our fewest number of recorded Sev1 incidents in our history was during Oracle World, right? And basically every DBA was in San Francisco getting trained on whatever. But the week after, we had the highest recorded number of Sev1 incidents. Why? Because they were all putting everything that they had learned in production, right? So anyway, as a development community, what we now see are a date-driven project, and so we have to cut every corner that can be cut in order to hit the date. So that means That means testing, security testing, capacity testing, deployment, manageability, so forth, right? All the non-functional requirements. And that means, at the end of each project, we have one more fragile piece of artifact in production, right? And so that's another downward spiral. And so Ward Cunningham said it best 15 years ago, right? Technical debt is what we feel the next time we try to make a change. So when I visualize technical debt, I view it like this, right? It is the accumulation of all the crap in the data center downstream, right, that accrue over decades where, each with a promise, that we're going to fix it when we have a little bit more time, right? So, technical debt is like financial debt in that it compounds, right? And so this, although bad, is not as bad as this, right? And so this is actually very bad for availability and also security, right? Because suppose you have an outage and you even know it's due to a cabling error, right? Which cable is it? It's that cable, right? But don't jiggle the cable because we know somewhere in that wiring cabinet, right? There's a loose cable, and if you touch the wrong one, right, the entire site will go down, right? 2 years ago. So, so that's certainly another, downward spiral. But there's actually something far more insidious that happens, which is that deployments start taking longer. So think of a friend, right, who had an application that used to take 5 minutes to deploy. So it's taking 10 minutes, starts taking an hour, starts taking a day, starts taking 2 days, right? And so 2 days, I think, is a threshold between sort of bad and intolerable because at least, if you're not Twitter, right? In most enterprises, if you have to do an upgrade and you just have to make sure it's open by 5 a.m. Pacific time, right? You can do it as long as you have the ops guys, start at 5:01 p.m., right? And work all night, throughout the entire weekend. But when it starts taking 3 days, right? Now, in general, now it takes heroics on everybody's part in order to finish the deploy, right? The DBAs, the network engineers, security engineers, and so forth. So what ends up happening is that it doesn't stop at 3 days. It takes a week, 2 weeks. The worst deployment I've ever seen was one that took 6 weeks to deploy. So that took about 1,300 manual, very error-prone steps, right? This is for a $6 billion a year revenue-generating application. And so at this point, something terrible happens, right? This is the conditions that cause the intertribal warfare between operations and development, right? So here's our friendly developer checking in code, right? They high-five each other in the parking lot, right? Go to the bar and buy drinks for everybody, not realizing that they set the entire data center on fire, right? And oh, by the way, we accidentally left logging turned on, and now we have cardholder data in the log files, right? What could go wrong? And so, what happens here is that, when deployments start taking longer, right, something, at this point, no one's achieving their goals. Features are not getting quickly into market. Deployments are starting to take longer. We have an ever-increasing number of 7 outages, right, and we have an ever-increasing number of, firefighting and operations, and we're increasingly unable to pay down technical debt, which includes all the security defects, re-architecturing needed, so forth. Does anyone have a friend that can resonate with at least some elements of the story? Could you just raise your hand, right? All of them, right? So the good news, or good bad news, is that you're not alone, right? I mean, I think we now have a better idea of what the symptomology that causes this. But of course, right? This is OWASP, right? There's one other very important constituency, which is Infosec, and I think there's no constituency that's more harmed by this downward spiral than Infosec, because it means that by the time we get to the buffet table has been emptied, right? There are no budget. There's no resources, there's no cycles left over, to fix and remediate all the defects that we found, right? And that means that we as a community are working on the lowest nutritional value work there is, which is compliance work, right? We're not even helping the organization really achieve its goals. At this point, we're just trying to keep the auditors away. So this is what I believe leads to a sense of hopelessness and despair, right? A sense that we are trapped in a system, right, that preordains failure and we are powerless to change the outcomes. So Josh Corman, good friend of all of ours, he did a study of burnout in Infosec, and he found that the rates of burnout in Infosec is off the charts. It's higher than first responders. It's higher than physicians in the ER, people doing multiple tours of duty in the military. And the 3 signs of burnout are fatigue, cynicism, right? Cynicism is often our core competency. And then the third one is illusions of self-efficacy, right? We think we're better than we are. And I think if we were to repeat the study with operations people, we'd find the same phenomena, right? Why? Because whenever we are put into a situation where we have to live with the downstream consequences of decisions made way upstream and live with them on a daily basis, that's what, is the most damaging thing we can do to another human being, right? Deprive them of their ability to change their own outcomes. Excuse me? All right. Thank you. So this down spiral happens everywhere. So what I want to do in 3 slides is, share with you, I think, the reasons why this happens to all of us. Independent financial of industry vertical, industry independent of company size, profit, not for profit, etc. And then share with you why organizations like Google, Amazon, Twitter, Pinterest, Etsy, these organizations that are implementing DevOps have really shown us a way out. So why does this happen everywhere? The first is that every organization, almost as a byproduct of how we're configured, creates what Dr. Goldratt called in the 1980s a core chronic conflict. In other words, every organization has to do two simultaneous things. We have to respond more quickly to urgent business needs, which means ship more features faster than ever. Right, that's what the head of development might say. And then, but on the other hand, we have to provide reliable, stable, secure service to the customer, right? And that's, the head of operations would often say, "Over my dead body." And by the way, maybe even the security person will say, "And I'll jump in too," right? And what I've learned in my journey is that that can quickly be arranged, right? Time to market will always trump availability, paying down technical debt, and so forth. And I think that's just a fact of life. But it does explain why the conflict. The second is, why is it every company? Why is it, only Google, Amazon, and so forth? And I think these numbers show why, is that every company is actually an IT company, regardless of what business we think we're in, right? 95% of capital projects have an IT component. You can't make a business decision without resulting at least in one IT change. Secondly, 50% of all capital spending is technology related. So I guess in my mind, right, we all know that, technology runs the back office, right, as the nervous system of the company. But if you look at these numbers, I think it's easy to see that it's actually the majority of the muscle mass as well, right? And I think the visceral proof point of this is that whenever the organization says, here's where we are and here's where we need to be, who's in the way? Who is conspiring to prevent the ultimate dreams and aspirations of the organization, right, from happening? Who is conspiring to constipate the flow of work, right, making sure that, the organization can never do what it actually wants to do? It's IT, right? And if you are, if you drill into that IT box, especially when you have multiple dev groups feeding into one shared IT operations group, that's a shared service, the bottleneck is operations. And I think that's a very vulnerable and uncomfortable place to be, even sometimes more uncomfortable than information security. So, Act 3, there must be a better way. I think what organizations like Google, Amazon, Twitter, and so forth have shown demonstrably is that there is a way to break this core chronic conflict. These are organizations that are doing a very high rate of change while preserving world-class reliability, stability, security, and so forth. So, I think when historians look back around this time period, plus or minus 3 years, they're going to say that something transformative happened, right? The way we worked, right, changed. And so I think, Lean will be a part of it, Agile will be a part of it, Cloud will be a part of it. But, I think the dominant factor will be DevOps. And then if we look for the seminal DevOps moment, they're all going to point to this presentation, which was given at the Velocity Conference in 2009. And so here's where organizations, where the unicorns go, right? Google, Amazon, they all share their biggest, ops and engineering problems. And so the presentation that was given was 10 deploys a day, at Flickr. And by all first-hand accounts, I was not there that year, but I was there the year after. Everyone who was there in that presentation said they knew they were in the presence of something historically significant, right? And so, had I been there, I think I would have been like maybe a lot of you, right? My reaction would have been like, "What? 10 deploys a day? They're lying, right? That's impossible, right? And even if it were possible, what sort of morons would actually want to do 10 deploys a day? It's irresponsible, reckless, and I'm guessing probably immoral, right? Because it's just not right. Once a year is about the right number. So, essentially what Allspaw and Hammond, by the way, who are Allspaw and Hammond? John Allspaw was the VP of Operations at Flickr. And Paul Hammond was the Director of Engineering at Yahoo. And so essentially what they were saying is that, Dev and Ops are very different, right? You got Dev is embodied by Spock, right? He gets to sit on the bridge. Captain Kirk actually asks some questions, actually listens to the answers, right? Ops is embodied by Scotty. He never gets invited to the meetings, right? Unless there's a 7 outage and the warp engines are down, right? And if I were Scotty, right, I'd roll my eyes and say, "What do you expect?" Right? We've deferred planned maintenance for 2 years, right? This is what happens. I'm out of here. But no, he saves the day. Information security, we are probably like these people, right? When we enter into a 3rd year of a repeat audit finding, who do we need to throw under the bus? Security management, right? But I think what attracted me so much about the DevOps community is that fundamentally it is, but look at its name, it's a community of boundary spanners. They said we need ops people who can think like devs, devs who can think like ops, right? And just to show you how deeply rooted this is, also at the Velocity Conference, a gentleman named Theo Schlossnagel said, yeah, this creates a nice summer of love, but DevOps is actually a terrible name. It's incomplete, prone to misinterpretation, because in his mind, it should be called Star Ops, or maybe more pedantically, .star Ops, right? Or, maybe more pedantically, every department ops, because in his talk, you can actually hear him say, "Where's information security? Where's QA? Where's where's the DBAs? Where's network engineering?" Because you need that whole tribe, right? You need all those disciplines to really sustain high, fast of flow of work and stability. So, in my mind, right, I think every once in a while you see a presentation that changes your world. And when I had the privilege of watching Justin, Neil, and Alex talk, I mean, in my mind, it was like, they've just crystallized where security fits in, and not only how Infosec can be treated with open arms by DevOps, but what exactly is the contribution that Infosec can provide DevOps that will result in, the ideal reaction of, thank you so much. I'm so glad that you were part of this project. I'm so glad you were part of this team. So I'm going to go in the remainder of the presentation sharing with you more practices and patterns. And is Nick Galbraith here by any chance? Oh, man, there are so many smart people in this conference. I'm just so excited to be here. Anyway, so one of the things I learned studying high performers with the Software Engineering Institute at Carnegie Mellon University is that in every field, high performers exist and high performers accelerate away from the herd. And so this is absolutely happening in the DevOps space as well. In 2009, we thought 10 deploys a day was fast. These days, that is merely average. Amazon has gone on record as of a year and a half ago saying that they are now routinely doing one deploy every 11.6 seconds, right? And so what is a deploy? It could be a feature being rolled out behind an A/B test, behind a feature toggle. It could be 10,000 new environments coming up. It could be a configuration change. All of that would count as one deploy. So, I think the rate of change is breathtaking. This is why I believe that, for any dev, test, ops, security person, we all have to learn to work in this type of work pattern, because the competitive advantage it brings to the businesses that we serve is so great. Why? I think it's, I'll tell you more why. So it's not just the unicorns, right? It's not just these organizations. It's also the horses too. And one of my favorite little pithy quotes was, if there's anything that horses hate, horses being enterprise IT organization, non-unicorns, horses hate hearing stories about unicorns, right? Because even though one can argue they're actually in the same species or genus, right? If you take a look at the rates of adoption by horses, I mean, it's astonishing. It's financial services, it's retailers, it's higher education, it's governments. And so the question is why? Why are they doing this? And I think the reason is that the value to the organization is even bigger than we thought. So about a year and a half ago, the folks at Puppet Labs, a configuration management vendor, they reached out and said, hey, can you help craft our DevOps survey of practice? And it was an opportunity to benchmark over 4,000 organizations, to really determine what, the health and habits of, organizations doing at the various stages of DevOps interest and adoption. And we found that there were three big surprises. The first was that the high performers exist, and they are massively outperforming the non-high performing peers. They're doing 30 times more frequent deployments, and they did them 8,000 times more quickly. In other words, if you take the amount of time it goes from code committed to test environment set up, test running, test accepted, deployment started, deployment ended, running in production, they could complete it in minutes or hours, whereas lower performers took months, weeks, months, or quarters, right? It doesn't help that it takes 42 weeks to get a security test, right? That's doesn't contribute to the great lead times. But so when they're not only doing more work, they're actually getting far better outcomes. They have twice the change success rate, right? So it's twice as likely to succeed without causing a service impairment, service down, or security incident. And when things do blow up, because Murphy does exist, they can fix it 12 times faster, right? So in our minds, this is just the first concrete empirical evidence that you can actually be more agile and more reliable at the same time. In fact, the two go hand in hand. You need both. How am I doing here so far? I mean, do you think that this is relevant to you? I just want to confirm. Okay, do you mind if I ask why? Makes you feel better? Why? Right. It's status quo preordains failure. It's not your fault. It's not our fault. Okay, so why is this so important? It's because of things like this. Scott Cook was the founder of Intuit, and when I first found this quote, I fell out of my chair, and then I thought these guys were morons, right? So he said for the peak season in TurboTax, they did 165 production changes during the peak tax filing season, right? And so my first reaction, these guys are idiots. Why would they do that? Because the way I was trained in retail, we were so afraid of the holiday outage, we had a change freeze from October 1 to January 30th, right? So why would these guys, do something that looks so reckless? It's because of this point right here. By doing A/B testing and making change, experimenting constantly in production, they were able to increase the conversion of the website, by 50%, right? So had they waited until April 16th, right, it would have been too late. They would have already lost the prospect to the customer, maybe never to return. So I think, our goal as information security practitioners is to show, hey, DevOps tests, there's a better way to do work, and the value to the organization is incalculable. And incidentally, this sets up the work patterns so that we can actually succeed as opposed to preordained failure. All right, so if there's anything that horses are good at, horses are also good at coming up with excuses about why they can't be unicorns. So one of the most interesting case studies I ran into last year was from Darren Haig. He is a operations architect at SAP. He runs the internal SAP instance at SAP, and he showed how he decreased the lead time of code commit to code running in production from 9 months to 1 week. So if there's any application that has been specifically engineered not to be agile, right, I submit to you SAP. I mean, I can't think of another application that is more cumbersome to change, right? And yet, if you can do it for SAP, right, it shows that you can actually do it for BEA WebLogic. You can do it with WebSphere. You can do it with even COBOL mainframe apps, right? So, it shows that you don't have to be Twitter. You don't have to be running open source software. You can even do it with, software that's been around for decades. So, if there's one book I would recommend to everybody, it would be this book, The Goal. That was written by Dr. Eliyahu Goldratt during the 1980s. And he is credited for changing how a generation of managers, how we thought about operating plants. And so this is now integrated into almost every MBA curriculum. And it's a novel about a plant manager who has to fix his cost and due date issues in 90 days, otherwise they shut the plant down. And so when I read this book 15 years ago, it changed my life. There was no doubt in my mind, even though I had never worked in a plant or certainly managed a plant, that the lessons in the book were relevant to us, right? Whether it was security, ops, or development. And so for a decade, we've been trying to write the goal for IT, and that's what the Phoenix Project is. And so there are many similarities between the goal and the Phoenix Project. That's not coincidental. We studied this book for over a decade, getting ready to write the book. But one of the things they do have in common is this Yoda, Mr. Miyagi-like character that speaks in kind of enigmatic, cryptic ways that are difficult to understand. And so our Yoda speaks in the language of the three ways. And so what I want to do is just share with you the principles that underpin DevOps, right? So the three ways, I think we should be able to derive all the patterns that we observe in DevOps organizations. So I'm going to share with you the principles and then specific concrete patterns. And I'm hoping, I'll be honest, I've deleted a bunch of the security slides because I want to give you as much ammo as possible to bring to the rest of your organization. So, the first way, we have to understand the flow of work as we go from left to right, from dev to ops, right? And, the goal is always to increase flow. If you listen to lean practitioners or Six Sigma folks, flow is a word that they use. And so in lean, in the DevOps community, kind of our favorite metric that we brag about is deploys per day. But in the lean community, the metric they care most about is lead time, right? There's a deeply held belief in lean that lead time is the best predictor of quality, of customer satisfaction, and employee happiness, right? And so the only thing they care about is lead time. So in manufacturing, it's measured by how long does it take to go from raw materials from one end of the plant to finished goods at the other. And so in my kind of myopic world, right, in the DevOps value stream, it's about code commit to running in production, right? Of course, testing and security is part of that. And we can never get fast flow if we are consciously passing defects downstream. We can't optimize for dev metrics or test metrics or ops metrics, security metrics. We have to sort of care about what helps the organization. And that's when we will have achieved what Deming would call profound appreciation of the system. So I had mentioned deploys per day versus lead time. And I think just kind of as a little mini benchmark, think of a friend who's associated with an application deployment. How many people here for that friend would say lead time is measured in minutes? Raise your hand. Nice. Hours? Days? Weeks? Months? quarters. Quarters is not unheard of, right? And by the way, if you have lead time measured in quarters, often it's blocked on operations because it takes 42 weeks to get a test environment, right? And so I used to believe that developers didn't like testing code. I mean, that was the only explanation I could come up with. But after observing kind of the quality of releases coming out, but it turns out that developers do want to test their code, and they're so desperate to code that to test their code that they'll just go to someone who has a reputation of being able to get an environment, right? You just never want to ask where'd it come from because somewhere someone's missing a server, right? So I think lead time, right? Great predictor of quality, customer satisfaction, and employee happiness. I think it's also a great indicator and predictor of cultural trust between ops and dev, and unfortunately, information security as well, right? If information security has a reputation of creating a bureaucracy that sucks the will to live out of everybody we touch, right? Focusing on technical minutia, right? Coming up with every reason to say no, right? That's going to be another one. But it's not only a predictor of cultural distrust and animosity between those different groups, it is also a good predictor of catastrophic deployments. And so we believe that one of the main reasons for catastrophic, world-class deployment failures, right, is that the first time the code is being integrated in a production-like environment was during the deploy. Right. In other words, the first time that anyone actually bothered to run it on a secure configuration that actually can withstand production like load is during the deployment, and of course nothing works. So if this is the case, then the countermeasure really is, and the behavior we observe in high performers is that operations must enable anyone to get an environment that resembles production with a click of a button, right? To spin a new instance up, to create a new VM, whatever, right? And so that anyone who wants one can get one without opening a ticket, without going through a security checklist, right? They can get it when they need it. And there's a common build mechanism that builds the dev, test, and production environments all at the same time. So, I think that one of the best uses of this is giving this to developers so that even in the earliest stages of the project, they can actually be writing, running, and testing the code in a production-like environment. So I will say this. I actually thought about 8 years ago when I saw Agile being rolled out in financial services, I thought it was morally wrong, right? I thought that it gave developers an excuse to ship crappier code more frequently, of which we downstream would have to clean up and live with forever. And yet, I genuinely believe now that, they have so much right. They talked about small batch sizes, ship more frequently, small development intervals. I just wish we could go back in time and add one clause to their definition of done. It is not sufficient to have working and shippable code at the end of each development interval, right? It should be demonstrated in a production-like environment. And by doing that, it means that even at the earliest stages of project, we will have integrated the code and the environment, and that has some shot at being secure, right? Tens of times, and certainly by the end of the project, integration and testing will have happened thousands of times, which massively reduces the deployment risk. How am I doing here so far? So far, so good? Okay. And just because I'm paranoid, does this seem relevant for Infosec? Mildly, or yes? Okay, good. All right, awesome. So let me give you another pattern, is we have to deploy smaller changes more frequently. One of the biggest sort of aha moments I had in my journey was the Facebook chat story. So this happened in 2008. If you look at how they shipped chat, I mean, it was, in my mind, like nothing I'd ever heard of before. And by the way, my first reaction when I heard the story was that, I rolled my eyes. I'm like, chat? I wrote one of those, as a sophomore in college, right? It's a trivial problem, but across 100 million users as an order n cube problem, right? Very difficult. It was one of the largest initiatives they had undertaken. It was their first use of Erlang in production, right? It took a year, and so what was interesting was that for every day during most of the project, they were deploying code into production, right, in a disabled state, hidden behind a feature toggle, right, so that the only people who could see it were internal Facebook employees. Moreover, they were actually using every Facebook browser chat, every Facebook session as a test harness. It was invisibly sending chat messages to the backend servers, right? And occasionally, testing for replies. So this means they actually had a year to test in production, right? test in production. Amazing, right? I used to think that was a joke. No, what a great thing, right? So when it came time to release and launch Facebook to the world, right? Overnight, 97 million users came on board, right? Why did it go so seamlessly and brilliantly? Because they had a year to prepare for it. So I think, the goal here is the win for security is that by deploying it to production, we can actually test in production in a way that doesn't have to cause disruption for the customer. How many people think that's amazing, right? That blew me away. By the way, there's another thing that happens here. It means that we can free ourselves from the learned behavior that deployments and releases hurt, right? We can deploy in the middle of the day like normal human beings, right? And that means we don't have to work all weekend at the expense of everyone around us. So an important part of this is decoupling deployments from features. Deployments is the promotion of code into production, often in a disabled state. Release is a marketing event. So our job as ops and engineering and security is to make sure that we can deploy into production safely, right? Marketing's job is making sure that the feature actually achieve the desired business outcome, right? And hold them accountable for was it worth building. So there's one other thing that I found astonishing. And maybe you've seen this before, but I didn't see this until last week. A friend of mine, he sent me an experiment. They actually did an experiment for this large printing company. They halved the release. In other words, they took the release interval and chopped it by half. In other words, fewer number of features, fewer number of code changes, and the number of incidents dropped by half, right? And so it really does show the smaller the unit of change, right, the odds of a higher change success rate and lower mean time to repair. Right, so to deploy more frequently is not wrong. In fact, it is a prerequisite to increasing flow and reducing lead time. Having studied these transformations, I believe there's actually kind of 6 stages of how organizations go from horse to unicorn. In fact, almost all the unicorns went through a very similar thing that looks just like the disease that horses have. The first in the goal, there's this wonderful phrase. In any flow of work, there's only one bottleneck. And any improvement not made at the bottleneck is an illusion. So his logical proof point of this was, if you improve something after the bottleneck, it will always be starved for work, waiting for work from the bottleneck. If you improve something before the bottleneck, work will just pile up at the bottleneck, waiting to be processed, right? And so, here's kind of how the constraint, the bottleneck moves in, from horse to unicorn. The first barrier to shorter lead times is how long does it take us to get an environment that's stable, secure, that's that we have some degree of mastery over, right? That we can trust in production. And so what the DevOps survey of practice showed was that there were 2 behaviors that every high performer had that none of the low performers had. The 2 questions that every high performer answered yes to were, I'll just go back, was, do you have all your production artifacts checked into version control? Meaning we can reproduce the production environment just by what's in the source code repository. The second is, do we have an automated code deployment process, right, which includes being able to create environments on demand, right? So if we can spin up environments in an automated way and we can put all our security checklists and hardening guidance into the build mechanism, right, that will break the first bottleneck. The second one is how long does it take to actually execute the code deploy? And again, the benchmarking showed that high performers had an automated deployment process. And if it wasn't completely automated, they at least reduced the number of handoffs, and they didn't have to wait 4 months or a month for a security review. That was baked into the earlier in the life cycle. After that, the bottleneck typically is how long does it take to set up the test environment and run the tests. You can't have multiple deploys a day if it takes 2 weeks to set up the tests, 4 weeks to run, right? And so, the way you break that bottleneck is you massively paralyze the tests, right? And I'll show you how Google does this later. And then after that, the constraint moves to development and product management. How many good business ideas can we come up with that we think are good use of the organization's time? Specifically, what is not, and I think that's where it should be. Operations and security cannot be the bottleneck of the organization, right? That's sort of not our job. Our job is to enable fast flow. So, and I just want to show you kind of what it looks like when when you decouple Oops, I missed one. So another bottleneck that I think security practitioners suffer more than I ever thought was overly tight architecture. We want to make the change. We want to fix the application defect, but we can't because we have to touch 15 other things, right? Because the application is so tightly coupled that not only can we not make the change, it turns out 15% of developers' time are in committee meetings trying to get approval by everybody, to make the change. The architecture committee, the other product teams, the platform committees, the security committee, and so forth. And so, there you have to decouple the architecture so that you can actually make changes more autonomously without, so much planning and process. Am I making sense? Right, and so here's what it looks like. Blackboard Learn, they're a learning management system. They're a publicly traded company. I got this graph last year. Here's an example of what it looks like when you are bound by architecture. So on this graph on the top is the number of lines in the code repo. The number of lines, this graph on the bottom is the number of code commits. And so David Ashman, the chief architect at Blackboard, said, our code was getting so tightly coupled that we couldn't make as many changes that we wanted to, right? Our developer productivity kept going down because 15% of our time was spent coding. The rest was in meetings. And so they said, we've got to fix this, just like Amazon did, just like Google did. And I even thought I heard a talk at Twitter about how they broke the front end up so they didn't have this big monolithic front end, although I think it's still there. Anyway. And so they built the building blocks, right? So notice that the number of lines of code in the repo actually went down. Where'd it go? It went here, right? Here's the building blocks where every sane developer wanted to work in the building blocks environment, where you could work in your own little module without impacting everybody else, so that you could have a whole bunch of autonomous groups working and being productive, as opposed to being in meetings, right? Okay. So outcomes of the first way. We have a single repo for code and environments. We have a deterministic release process that's secure, right, baked into the build mechanism. All the dev, test, and production environments are synchronized, right, long before the big deployment starts. We're starting to build the basis of what they call continuous delivery. We're freeing ourselves from this learned behavior that deployments hurt, and we're shrinking lead times, right? We're going from months to weeks to ideally days. To on demand. We're keeping up with the rest of the business. And when we do that, that's how we increase, the number of deploys per day. Any questions, comments, concerns before we go to the second way? Awesome. Thumbs up. So far, so good? Okay. First way is flow from left to right. The second way is feedback from right to left. So the goal of the second way, right, is to take the learnings that we can only learn during a production outage, during a service impairment, during a security breach, and feed it to the very beginning of the dev lifecycle so that we can ideally prevent it from ever happening again. And if we can't prevent it, at least be able to enable quicker detection and recovery, right? Prevent, detect, correct. And so the principles are we have to respond to the needs of all customers, both internal and external. And so I think we're all good at knowing who the external customer is. It's the person behind the browser, whether it's at home or in our businesses. But in the lean community, they say the most important customer is not them. It's the internal customer, as defined by the next downstream step. Whoever we give our work to, right? That's who we need to be optimizing our work for, because it has to be complete, accurate, design, everything optimized for them. And we have to shorten and amplify feedback loops. The goal is to make sure, and this is, nowhere is it more important than information security, right? Is that if we see a bad behavior, we want to prevent it from happening again in the future. Otherwise, it's going to happen again and again. And by doing this is how we create quality at the source, right? And this is how we achieve this platitude of find defects early. So how does this happen? I think where we look to in manufacturing is the Toyota Andon cord. This is considered the paragon of the shortest feedback loop you can get. And so when I was trained in the Toyota Kata, right, it's really true. You go to any plant modeled after the Toyota production system, on the top of every work center is this Andon cord. And so if there's a part defective, or if the parts aren't there, or even if the work instructions, the work is taking longer than documented, you pull the cord. What happens when you pull the cord? It stops the entire assembly line. Literally, trucks stop coming out the other side, right? Can anyone guess for a typical Toyota plant how many times the Andon cord is pulled in a given day? Order of magnitude. 0, higher, 5, higher. 100, higher. It's 3,500. Wow, right? And so here, just to let this sink in, how many times in a given day have you seen something in work being done where you think someone really should pull the Andon cord, right? Yeah, and so the question is, why would Toyota do something so disruptive, right? Every time someone pulls a cord, they're stopping the line. Because it's the only way they have found over decades of experience to maintain a production rate of 2,000 vehicles a day. That's one finished truck going off the line every 55 seconds. So if you don't fix the defect at the work center, if you allow technical debt to accrue downstream, right, it becomes far more expensive, maybe even impossible to fix. Intervention, countermeasure, and uncord. So what does feedback look like in the DevOps value stream? I think this is one of the best embodiments of this philosophy. Patrick Lightbody, he's the head of marketing now at New Relic. God, amazing vendor. He was the founder of a company called BrowserMob before that. It was one of the first massive load testing tools in the cloud. And he said, we found that when we woke up developers at 2 a.m., defects got fixed faster than ever, right? I was like, wow. Right, and it's not because he didn't like developers. He wasn't calling random developers at random times, right? He made sure that there was shared pain, because you can't have shared goals unless you've got shared pain. And so one of the hallmarks of DevOps organizations is that developers are put on pager rotation just like operations, right? In fact, dev managers are also put on pager rotation. And so I think this is a way to make sure that we never have this illusion that we're shipping features achieving the goal when all we're doing is shipping unusable code downstream. So, Werner Vogel, CTO of Amazon, says it even better. You build it, you run it, right? So I think, let me share with you a couple of, evidence point. So why would they do this? So Google, you can see this in the productivity numbers. Google has 15,000 engineers working on 4,000 simultaneous projects. All code is checked into one source code repo that I think is like 4 terabytes. I mean, it's just like huge. 5,500 code commits a day, each resulting in a production deploy. 75 million test cases run daily. It doesn't hurt that they actually have more servers than God, but that's why would they do that, right? Because Aaron Massari, part of the SCM team, the dev tooling team at Google, says automated tests transform fear into boredom, right? And so what better ecosystem is there for information security when there's an automated deployment pipeline that makes sure that every time a developer commits code, it runs a test and developers say thank you, right? So how do we get there? Let me 13 minutes. So just to kind of share with you more sort of breathtaking awesomeness of the unicorns, right? This presentation was given by Tom Limoncelli. He's one of the site reliability engineers at Google. And so SREs, they're considered the Uber sysadmins at Google. They're good at ops. They can talk to developers. And he was describing that at Google, they have a policy that says for any new service or application, the developers must self-manage their own code for 6 months, right? Why? Because until they can live with it, why should operations live with it, right? And so they have this thing called the hands-off readiness review, where you have to show that it can actually run without people being woken up at 2 a.m. all the time. It looks like a production checklist, but the resemblance stops there. What happens when something goes into production, passes the HRR, and it goes fragile, right? Because Murphy does exist. They have something called the handback, right? That essentially is saying, hey, your puppy is cute, beautiful, it has tons of business value, lots of potential, but she keeps pooping on the floor, right? And here's your puppy back. Give it back to me when she's house trained, right? And we'll run her through the HRR again, right? So how many people here would love to have a handback clause, right? This is just not production ready. And I think this really shows the mutual respect between dev and ops. And I think, forgive me for belaboring this point, when dev and ops are at odds, information security gets aced out of the game, right? And so when dev and ops are actually working together, creating fast flow and not blowing up the site every day, right? That creates the conditions where information security can really help secure the applications, data, and the organization. Okay, so the handback is a very significant, severe source of feedback. Type of feedback. Here's another one that's much gentler, but I think far more important and pervasive. This is John Alspaugh. He's now the EVP of Tech Ops at Etsy, one of the unicorns. Right? Where is that? Zane? Wait, did someone say woo? No, everyone loves Etsy. All right, so he said we've created a culture where every developer must create production telemetry for the features they write. In other words, if it's important enough to write, it's important enough to instrument. And so I'm showing this picture not to show John Alspaugh, although he is quite dashing. I'm going to show you what's behind him. They've gone on record saying that they have over 250,000 metrics being generated in production all the time. That's features, application health, database, storage, OS, network, firewalls, everything. And and Nick Galbraith, right, even has a couple of his, on the big board. And what they did was they said, they invested so much effort into tools like Statsd and Graphite, where a developer has to add one line of code, and bang, right, they have one more graph in production. Here's whatever they're trying to instrument, and each vertical line is a deploy. And what is astonishing to me is that no developer will do a deploy without staring at these metrics. I mean, people actually look at them, right? When I think about the PCI compliance breach studies, right, that why did it take 3 quarters, to actually detect that we were losing cardholder data? No one was looking at the logs, right? So how amazing is it that as security we can actually instrument things and people will actually pay attention. So I submit to you as proof as this. I love touring DevOps organizations and watching them work. So this is Rally Software. They make the agile planning software. It's about a $100 million a year company, publicly traded. This guy's name is Charun Reddy, Director of IT Ops. And so you can see the panes of glass behind them, all the production telemetry. This is actually coming out. They feed it into Tableau. They have a ops engineer who's a statistician who feeds it all into R, right? Because they care about statistics. They want to find variance early before it causes something catastrophic. So right before I took this picture, someone had whispered to Charun something like that the lithium crystals are fluctuating. We're down 30%. What should we do, Captain? And everyone's looking at these metrics, going, "Is this a storage issue or is this a database issue?" And I think I actually pissed him off, right? I asked, "Are we actually watching a Sev1 outage in progress?" And he's like, No. We just saw something flapping, and we just want to determine what caused it before it causes something more significant, right? High performers find variance early before it causes a bigger variance, like a security breach. So, by the way, and so the other 8 minutes. Okay, we can do this. So one of the stories that these guys tell is how they refactored and re-architected their flagship product to reduce the deployment cadence from 8 weeks down to 2 weeks to 5 minutes. It turns out there was one specific problematic module that was so tightly coupled that it touched every part of the application that they decided to refactor first. It turns out that application was the authentication module, right? Right? What? Right? I mean, my reaction was like, "You're kidding me. You guys are idiots, right? I mean, you screw up the authentication module, you could accidentally disclose, all your customer data." But apparently, it was so critical, right? Because they wanted to decouple, the authentication module from everything else. And I think what I found so astonishing was the care that the developers, the security people, and the ops people took to do this. It took them 8 weeks to refactor the module. They decoupled the code, and they ran it side by side for a year, making sure that the inputs and the outputs were identical. Then and only then did they cut over to the decoupled module. I mean, I actually had tears in my eyes. I was like, I want every security friend I have to know, like, the care and diligence they took, right? Because developers actually do care about, things that we care about. Does anyone sort of like kind of get excited and get weepy at that story? I really do. So, and then we can't forget about the ultimate form of feedback, right? So in 2012, I got to see Justin. Could you please stand up, Justin? Because everyone should pet Justin before the day is over. I mean, he is like Justin, Neil Matadel, and Alex Smolin, who apparently is dead now because I haven't seen him in years. They gave this amazing talk that I would put in my mind as a security practitioner up there with the Allspaw Hammond presentation, because in my mind it showed how everybody's going to be working in 10 years. And so if I may paraphrase the story, he's describing how, they were all hired after a rather large security incident happened, which was the President of Barack Obama, the Barack Obama account being hacked, in which the consequence was there was an FTC trade injunction that said thou shalt have an information security program for the next 25 years, right? And so their challenge was, how do we affect the daily work of development and operations, right? So that we have a prayer of creating a secure code, secure environments, and so forth. And they described a whole set of tools, which included SADB, Phantom Gang, but the one that really blew me away was Brakeman. It's a static code analysis tool that is intended to be used in the daily work of development. So certainly, find defects early when you commit code into production, right? So you can find it before the big production deploy. But more importantly, the ideal use case is every time a developer hits save, they might get an email saying, "Hey, we just detected the potential SQL injection vulnerability. Here's how to fix it," right? And then when they fix it, hit save. They'll get another congratulations email saying, "Thank you so much. Thank you for fixing the vulnerability, right? Please rate our feedback. Please rate our advice on a scale of 1 to 5 stars," right? And in my mind, that is, in my in my mind, it is like the only way that we can sufficiently change the way how code is written in daily operations and the environment as well. Justin, I want to make sure I haven't overstated anything. I know that you might have some caveats on that, but no, it was in the demo video. Yeah. Oh, bullshit. Oh, yeah. It's like false positive. F you. and I think it actually floods Neil's inbox with 100,000 emails. Feedback, right? Feedback is love. So I'm going to skip the third way. I just want to share with you one thing that might be my biggest aha moment in the last year, which is that I think the days of determining whether it's safe to make a change or not based on an essay contest that goes into a change management meeting is coming to a close. That instead, it really should be based on, the automated test suite, right? And if something bad happened, in fact, four minutes. I do want to share with this story because in my mind, I think this is like one of the biggest challenges we have as a community. So I was talking with John Allspawn, Jez Humble. He wrote the Continuous Delivery book. And we were discussing the Knight Capital failure. And it was probably the most traumatic call I've ever had because I was on the brink of existential despair for 6 weeks because it said that everything I knew was wrong. Right? And I'll tell you what they convinced me of. So the Knight Capital failure was the famous $400 million trading loss, right, caused by a deployment error that they couldn't turn off, right, and that the firm actually got liquidated over the weekend, right, because it actually caused systemic risks to the organization due to a deployment error. So the typical narrative of the failure, of the accident, was that it was a change control failure, which I think is valid, or it was a testing failure, which is also equally valid. But what they convinced me of was that the low trust command and control countermeasures that you would put into place preordain the future likelihood of a future failure. Why? So a change control countermeasure would be you put one more level of signing authority needed, to make the change, right? And what they convinced me of was, holy cow, by removing the feedback between the person actually doing the work and the person making the decision increases, the chance of a future failure. With me so far? The second piece is by doing more testing, right, especially if it involves more manual testing, it means making changes less frequently, right, because we have to test more, right? And so we have shown over and over, right, that as the batch size of the change increases, change success rate goes down, mean time to repair goes up, right? And so what does that mean? It means the only countermeasure is you have to make changes more frequently with less supervision. And I don't know how you sell that argument to the organizations that we might have screwed before, right? I think what they're going to say is, let me get this right. You made a big mistake that caused something catastrophic, and you want to do it more often with less supervision, right? Right? Right. And yet, there's no doubt in my mind that that is the way to go, right? Because that is what every unicorn has had to go through. So, I think, studying how organizations transform from a low trust organization that's command and control to one that's high trust, I think is going to be one of the bigger management challenges that we have as a community. That's not just Infosec, that's operations and development as well. And that's something that we actually put into the 2013 DevOps survey of practice is, we're trying to confirm the hypothesis that you really do need high trust cultures, right, that don't have approvals. That instead it really rely on the judgment. Just to show you what I think a change management meeting will look like in 10 years, John Allspaw, he was describing this ritual. I think Etsy, Facebook, they have this ritual where every junior engineer on their first week of work will do a deploy, right? And if the deploy fails, they're not going to blame the engineer. They're going to say, oh, wow, we should have a test to prevent that from happening. So a junior engineer at Etsy asked John Allspaw, is it okay for me to make this change? Right? It was like an HTML change. And his response was, I don't know. Is it? I was like, wow. And that, in my mind, explained why John Allspaw has talked more like a philosopher than an ops guy, right? Because he's a high trust management style guy. So, I think that's another thing that we're going to have to help encourage. So second way is defect security issues getting faster than ever, more usable stories. Everyone's getting more work done. everyone's communicating and coordinating better. I'll talk about the third way, about things like Chaos Monkey and so forth, if you really, really want. But let me just tell you why I think this is important. Because the status quo preordains failure. There's a reason why any person who's put decades into their career doing information security, leaves, right? That when we feel like it is increasingly hopeless, right, and we are powerless to change the outcomes, right, that does damage to us as human beings, right, and that causes damage to us, not just us, but also the people around us. I think about, the days I've woken up and my jaw hurts from clenching my jaw all night because I've had to deal with cleaning up the mess of somebody who didn't know what they was doing, and they made a decision months ago, right? There is a better way, and I think the DevOps community is showing what that better way looks like, and right, it is Dev Security Ops. How much business value is on the table if we solve this problem? A friend of mine, we did a calculation. He was a co-author. He's a co-author. We said, how much business value is there on the table for us to recapture if we could just have the amount of waste in the IT value stream and redeploy it in a way where we could 5 times the value back? And the number we came up with was $2.6 trillion. Right? So, that's a huge number, right? That's more than the annual economic output of Germany. Right? So imagine being able to re-inject $2.6 trillion into the economy. How many more projects can we fund? What does that do to productivity? What does that do to standards of living? Right? There's no doubt in my mind, how DevOps and Infosec work will unlock the next surge of productivity, the likes of which we have not seen in 30 years when manufacturing was transformed by lean. But in my mind, the way I think about this number is through the eyes of my kids. I have a 6-year-old and 2 identical twin 3-year-olds. You put $2.6 trillion back into the economy over 2 decades. Now you make a material impact on things like, health, wealth, and, things like world peace, right, become possible. So in my mind, there is, this is a problem we're solving. I guess my fondest hope is, if I could wave a magic wand, is that, in the last hour I've convinced you that, failure is preordained in status quo and that there is a better way, and that I'm hoping that this will generate some ideas of some things they can take back and start some conversations with your dev and ops peers that lead to awesome greatness so you too can be as great as Neil and Justin. Our goal is to positively impact the lives of 1 million IT practitioners by the year 2017. One of the ways that we're doing this is making the first half of the Phoenix project available for free. So anyone who wants a copy of the book, or if you want to give it to somebody, just go to that site, and send you'll get a PDF back and spread it around. Studies have shown over and over that the most effective mode of persuasion is storytelling, right? Whenever the goal is to activate the mirror neurons in someone else, storytelling is the way to do it. And so that's the reason why we wrote the Phoenix Project in the form of a novel. And, and I'm hoping that by spreading this, excerpt around, you will find your fellow travelers who say, yeah, I see this problem, and why don't we work together to actually, make it go away and, replicate the transformation that every unicorn has gone through. Let me just share with you 3 things I'm working on that if you're interested, just email me. I'm working with a senior manager at Ernst & Young. Because we believe that one of the biggest impediments to DevOps adoption are the auditors. Nothing will freak out auditors more than seeing devs do their own deploys, right? And without change approvals, right? Forget about it. So what we're trying to do is create a set of worksheets where we can show that we are actually managing the risks, and here's how we evidence it, and do it with the firm that actually is the audit firm of record of Google, Amazon, Rackspace, so forth. We are hopefully weeks away from having the first draft of the DevOps cookbook that really is meant to be a prescriptive set of steps of how you go from good to great. And if you're interested in seeing an early draft, or better yet, scrutinizing and reviewing it, please let me know, and we can make that so for you. So that's how to reach me. Thank you so much for your time, and I'll see you later tonight. Thank you.